Asterisk, epic space footage planets in orbit. Transitions, zooming in on Earth or another planet. Asterisk, Mercury, the smallest and closest to the Sun. Venus, Earth's twin in size, but not in temperament. Earth, the only planet known to harbor life. Mars, the red world, with a history of water. Asterisk, Jupiter, the largest, with swirling storms and 90 moons. Saturn, with its iconic rings and hidden secrets. Uranus, icy, tilted, and oddly mysterious. Neptune, cold, deep blue, and stormy. Mercury, the smallest, fastest, and most sun-scorched planet in the solar system. Asterisk, extreme environment. Despite being the closest planet to the Sun, Mercury isn't the hottest Venus holds that title. But don't be fooled. Mercury is a planet of extremes. Daytime temperatures, up to 430 degrees Celsius 800 degrees Fahrenheit. Nighttime temperatures, as low as -180 degrees Celsius, -290 degrees Fahrenheit. Atmosphere, almost none, just a thin exosphere of hydrogen, helium, and oxygen, with no atmosphere to trap heat or protect it from space. Temperatures swing wildly. Days last the equivalent of 176 Earth days, and nights are freezing cold. Surface and terrain. Mercury looks like our moon, gray, cratered, and ancient. Its surface has been battered by asteroids and comets for billions of years, forming enormous impact basins like the Caloris Basin, over 1,500 kilometers wide. Magnetic field and core. Mercury may be small, but it's not simple. It has a surprising global magnetic field, something we didn't expect from a planet its size. Scientists believe its outer core is still molten, creating a magnetic dynamo similar to Earth's. In fact, Mercury's core makes up 85% of the planet's volume. That's the largest quartz-to-crust ratio of any planet in the solar system. Water, ice on Mercury. Here's a surprise. In the permanent shadows of polar craters where sunlight never reaches, NASA has detected water ice. Yes, frozen water on the hottest planet near the Sun. A paradox that shows just how strange space can be. Orbit and speed. Mercury is the fastest orbiting planet in the solar system, zipping around the Sun at nearly 48 kilometers per second. It completes an orbit every 88 Earth days, but because of its slow rotation, a single day-night cycle on Mercury lasts 176 Earth days. Missions to Mercury. Only 2 spacecraft have ever visited Mercury. NASA's Mariner 10 in the 1970s, and Messenger, which orbited Mercury from 2011 to 2015. Messenger changed everything, mapping 100% of Mercury's surface, revealing its magnetic field, and discovering volcanic plains and unusual chemical elements. And the next chapter is already underway. The Bepi-Colombo mission, a collaboration between ESA and JAXA, is en route right now. When it arrives in 2025, it will provide even more detailed data on Mercury's composition and history. Shrinking planet. In 2025, scientists confirmed that Mercury has been shrinking for billions of years. As its large core cools, it contracts, causing the surface to wrinkle and form giant cliff-like structures, called lobates, carps. Since its formation, Mercury has shrunk by up to 11 kilometers in radius, a slow but significant transformation. Why Mercury matters. So what can we learn from this tiny, battered world? Planetary formation. Mercury's enormous core gives clues to early solar system collisions. Magnetism. Why does such a small planet still have a magnetic field? Habitability. Limits. What happens to a planet this close to its star? Mercury challenges what we thought we knew, and it's only just starting to tell its story. Venus. This is Venus, our twin in size, but our polar opposite in every other way. Asterisk. Shrouded in mystery. Venus is completely hidden beneath thick clouds. You can't see its surface, not even with powerful telescopes. Its atmosphere is a choking blanket of carbon dioxide, with clouds of sulfuric acid that reflect sunlight so well. Venus is one of the brightest objects in our night sky. But beneath that beautiful glow is a nightmare. Hellish surface conditions, surface temperature, approximately 465 degrees Celsius, 869 degrees Fahrenheit, hotter than Mercury atmospheric pressure, 92 times Earth's, like being 1 kilometer underwater, winds up to 360 kilometers per hour, 224 miles per hour in the upper atmosphere, days longer than years. One Venus day equals 243 Earth days. Venus is so hot, it could melt lead, and if you stepped on the surface, you'd be crushed, cooked, and dissolved in acidol at once. Exploring Venus at great cost, no spacecraft has lasted more than a few hours on Venus' surface. In the 1970s and 80s, Soviet Venera landers managed to transmit the first and only photos from the surface. Since then, orbiters like NASA's Magellan have used radar to map the terrain, revealing mountains, volcanoes, and vast plains of lava. Volcano world. Venus is covered in ancient volcanoes, but are they still active today? In 2023, scientists confirmed signs of recent volcanic activity, a change in surface features over just 8 months, suggesting a vent opened and lava flowed. This makes Venus only the third known volcanically active planet in the solar system after Earth and Io, a moon of Jupiter. The runaway greenhouse effect. Venus wasn't always like this. It may have once had oceans, clouds, and a milder climate, possibly for billions of years. But something triggered a runaway greenhouse effect. Carbon dioxide trapped more and more heat, boiling away any oceans, thickening the atmosphere, and transforming the planet into a hellscape. Venus is a warning, a preview of what happens when a planet loses control of its climate. Search for life in the clouds. Life on the surface is impossible. But in the upper clouds, where temperatures and pressures are Earth-like, there may be a slim chance. In 2020, scientists detected a possible biosignature, phosphine, a chemical that on Earth is associated with microbes. The data remains controversial, but it reignited the question: could microbial life exist in the clouds of Venus? Future missions: Da Vinci and Veritas. NASA is sending 2 new missions to Venus, Da Vinci and Veritas. Da Vinci will descend through Venus's atmosphere, analyzing its gases layer by layer. Veritas will map the surface in ultra-high resolution, revealing Venus's geological secrets. After decades of silence, we're finally going back to our twisted twin. Why Venus matters. Climate science. Understanding how a habitable world turned hostile. Planetary geology, volcanism, tectonics, and atmospheric evolution. Life in extreme environments. Can anything survive in such harsh conditions? Venus is a mirror, one that shows us how fragile a planet's balance can be. It may be Earth's twin, but it's also a stark warning. Earth, home, the only planet we know that hosts life, and possibly the most unique place in the universe. Asterisk. Life supporting conditions. Earth is a miracle of balance. Its temperature, atmosphere, and position in the solar system are just right to support liquid water and life. Atmosphere, 78%. Nitrogen, 21%. Oxygen. Average temperature, approximately 15 degrees Celsius, 59 degrees Fahrenheit. Surface, approximately 71% water. 1 moon. Tilted axis. Magnetic field. Its magnetic field protects us from solar radiation. The ozone layer shields us from harmful ultraviolet rays, and the moon stabilizes our orbit and tides. Biodiversity. Life in every niche, from ocean trenches to mountain peaks, from rainforests to arid deserts. Earth bursts with life. Millions of species, complex ecosystems, and us. No other planet we know of has such biodiversity or the right chemical recipe to sustain it. Dynamic planet Earth is always changing. Beneath our feet, tectonic plates shift continents. Volcanoes shape land. Earthquakes reshape entire regions. This geological activity recycles nutrients, maintains climate balance, and builds new land over time. A violent history, but Earth wasn't always this calm. In its early history, Earth was a molten sphere bombarded by asteroids and comets. The Moon itself was born from a colossal impact and ancient collision with a Mars-sized body we call Theia. The perfect distance Earth orbits the Sun in the Goldilocks zone, not too hot, not too cold, just the right distance for liquid water. It rotates every 24 hours, giving us day and night, and it orbits the Sun every 365.25 days, 1 year. Its 23.5 axial tilt gives us seasons a rhythm for life to follow. Earth from space. When we look at Earth from space, we see no borders, no politics, just one world, spinning silently in the dark. Astronauts often say that seeing Earth from above changes you. It reminds you how small, fragile, and precious this planet really is. The only life we know, despite thousands of exoplanet discoveries, we found no confirmed sign of life anywhere else, not even microbial. That makes Earth's biosphere more than beautiful, it makes it rare, and the more we study other planets, the more we understand how lucky we are to be here. Why Earth matters, it's our reference point, the only example of a habitable world. It teaches us what to look for in exoplanets, and it reminds us that planets can change sometimes fast, and not always for the better. Earth is not just another planet, it's our home, and for now, it's the only home we have. Mars *. Welcome to Mars, the red planet. A world that may have once looked a lot like Earth, and one that could one day be our second home. Mars, at a glance diameter, approximately 6,792 kilometers, just over half of Earth's. Gravity, approximately 38% of Earth length of day, 24.6 hours length of year, 687 Earth days. Atmosphere, approximately 95% carbon dioxide. Thin and cold surface temperature ranges from -125 degrees Celsius to 20 degrees Celsius a day. On Mars is almost like a day on Earth, but that's where the similarities end. Jupiter. This is Jupiter, king of the planets, ruler of storms, and the ultimate Geon *, massive scale diameter, approximately 143,000 kilometers, 11 Earth's mass, greater than 300 Earth volume, greater than 1,300. Earth's gravity, 2.5 stronger than Earth's number of known moons, 95 plus orbital period, 11.86 Earth years. Day length, 9 hours, 55 minutes, fastest of all planets. If Jupiter were just 80 times more massive, it could have become a star. But even as a planet, it reshaped the solar system, pulling in comets, redirecting asteroids, and influencing the orbits of other worlds. The atmosphere and great red spot Jupiter is made mostly of hydrogen and helium, like the Sun, but it doesn't have a solid surface. What you see are cloud-striped, swirling bands of gas, moving at different speeds and directions. Its most iconic feature, the Great Red Spot, a raging storm larger than Earth, swirling for centuries. But even that is just one of many. Storms, lightning bolts larger than entire cities flash deep within Jupiter's clouds. Magnetosphere and radiation. Jupiter has the strongest magnetic field of any planet, 14 times stronger than Earth's. Its magnetosphere stretches over 7 million kilometers, forming a radiation belt so intense it would fry electronics in minutes. Jupiter's polar auroras are bigger, brighter, and more powerful than any seen on Earth. Internal structure and metallic hydrogen below its clouds. Jupiter's pressure increases dramatically. Hydrogen gas becomes liquid, then metallic. This exotic metallic hydrogen may be what drives Jupiter's magnetic field, acting like a massive, spinning dynamo. Jupiter's moons. Mini solar system orbiting Jupiter is a system so complex, it's like a miniature solar system. Among its 90 moons, first stand out the Galilean moons, Io volcanic world, with hundreds of active volcanoes. Europa, icy crust over a subsurface ocean. Ganymede, the largest moon in the solar system, bigger than Mercury Callisto, ancient, cratered, and possibly harboring a hidden ocean. Each moon is unique, but Europa holds special interest. Beneath its icy shell may lie a global ocean, with more water than all of Earth's oceans combined. Where there's water, there could be life. Missions to Jupiter. Jupiter has been visited by several spacecraft: Pioneer, Voyager, Galileo, Cassini, and currently, Juno. Juno is giving us our closest, most detailed views of Jupiter, ever diving close to its cloud tops, measuring its gravity, and mapping its magnetic field. Visual: Juno orbiting, beaming data, cloud zooms, and 3D renderings of internal layers, and more is coming. JUICE ESA, Jupiter Icy Moons Explorer, launching in 2023, arriving in the 2030s. Europa Clipper, NASA, launching soon. To study Europa in detail. Why Jupiter matters. It shaped the solar system. Its gravity influenced planetary orbits and protected Earth from impacts. Its moons may hold alien oceans and, possibly, alien life. And its extreme storms teach us about atmospheric science on a scale we can't test on Earth. Jupiter is more than just a giant. It's a window into how gas giants work across the galaxy and a gatekeeper to the mysteries of its icy moons. The landscape. Mars is a frozen desert wind, carved, cratered, and painted in iron-rich dust that gives it its red hue, but buried beneath that dust is evidence of a much wetter, warmer past. We see ancient river valleys, lake beds, and even deltas. Mars once had flowing water and possibly oceans. Olympus Mons and Volles Marineris. Mars is home to the tallest volcano in the solar system, Olympus Mons. It's about 22 kilometers high, nearly 3 times the height of Mount Everest. And then there's Valles Marineris, a canyon system stretching over 4,000 kilometers, 10 times longer than Earth's Grand Canyon. It's not just dramatic, it's colossal. Was there life on Mars? Billions of years ago, Mars had liquid water, a thicker atmosphere, and possibly the right conditions for life. Rovers like Curiosity and Perseverance are searching for clues of ancient microbial life, hidden in rocks and soil. In 2021, Perseverance landed in Jezero Crater, an ancient lakebed. It's collecting samples that may one day be returned to Earth. What those samples contain could change everything. A magnetic mystery. One major difference between Mars and Earth. Mars lost its global magnetic field long ago. Without it, solar winds stripped away most of its atmosphere, turning a once potentially habitable world into a frozen desert. Rovers, orbiters, and ingenuity. Mars is the most explored planet in the solar system besides Earth. Orbiters: Maven, Mars, Odyssey, Mars Express landers, Insight, Viking Eye and Eye rovers, Spirit, Opportunity, Curiosity, Perseverance helicopter, Ingenuity, the first aircraft to fly on another planet. Each mission uncovers new clues and new questions. Water today. Mars may still have water frozen underground, or as briny, salty flows during warmer seasons. In 2018, a radar scan revealed a possible underground lake beneath the southern polar ice cap. Could microbes still survive deep below the surface? If they do, we might not be alone after all. The next frontier. Humans on Mars. NASA, SpaceX, and international space agencies have their eyes set on Mars as the next giant leap for humankind. We may see the first humans set foot on Mars within the next 2 decades. Challenges: radiation, resources, thin atmosphere solutions, underground habitats, growing food, local water extraction. Mars is no longer just a dream. It's a destination in the making. Why Mars matters: it teaches us about planetary evolution. It may hold evidence of life beyond Earth, and it could be our future home. Mars is both a memory of what might have been, and a promise of what could be. A planet where we may one day stand and look back at Earth glowing in the sky. Saturn *, Saturn's second largest planet in the solar system, and the most breathtaking. Quick facts: diameter, approximately 120,500 kilometers, about 9.5 Earth's mass, approximately 95 times, Earth's day length, approximately 10.7 hours. Year length, approximately 29.5. Earth years. Composition: hydrogen and helium. Known moons, 146 plus, including Titan and Enceladus. Saturn is massive, but it's the least dense planet in the solar system. If you could find a bathtub big enough, Saturn would float. The rings of Saturn. What truly sets Saturn apart are its rings: vast, complex, and surprisingly thin. With up to 282,000 km thickness, only 10 meters to 1 kilometer, in most places made of ice, dust, and rock, ranging in size from grains to house chunks. They may look solid, but they're made of countless orbiting particles. Some theories suggest Saturn's rings are relatively young, maybe just 100 million years old. Others say they formed with the planet. Saturn's atmosphere and hexagon storm like Jupiter. Saturn is a gas giant with no solid surface. Its clouds form bands and storms, some thousands of kilometers across. At its north pole, a strange and stable structure exists, a hexagonal storm, 6 perfectly aligned sides, rotating in place for decades. The cause, still debated. But no other planet has anything like it. Magnetic field and interior. Saturn has a powerful magnetic field, though not as strong as Jupiter's. Its core is believed to be rocky, surrounded by layers of metallic hydrogen and helium. Recent data shows that Saturn's core may be fuzzy, blending into its outer layers in a way we didn't expect. Saturn's moons, a system of wonders. Saturn's ring system is only half the story. Its moons are a world of their own. Titan is the second largest moon in the solar system, bigger than Mercury. Atmosphere, dense, nitrogen-rich surface. Lakes and rivers not of water, but liquid, methane, and ethane. Possibility of life. Some scientists believe exotic life could exist in these alien seas. Enceladus. Then there's Enceladus, a small, icy moon with a shocking secret. In 2005, the Cassini spacecraft discovered plumes of water vapor erupting from its south pole. Suggests a subsurface ocean contains organic molecules heated by tidal forces from Saturn. Enceladus may be one of the best places in the solar system to search for life. The Cassini mission, a legacy of discovery. No spacecraft revealed more about Saturn than Cassini. Launched in 1997, it orbited Saturn for 13 years. Discovered new moons. Flew between Saturn and its rings. Sent a probe. Huygens to Titan captured the most detailed images ever of Saturn's system. Cassini ended its mission in 2017 by diving into Saturn's atmosphere. Grand finale, designed to avoid contaminating any potentially habitable moons. Why Saturn matters. Its rings challenge our understanding of planetary formation. Its moons, especially Enceladus and Titan, may harbor life. And its beauty reminds us how diverse and dynamic the solar system really is. Saturn is a masterpiece of nature, layered, mysterious, and alive with possibilities. But beyond the beauty lies the strange and tilted world of Uranus. Uranus *. This is Uranus, the first planet discovered in modern times, and one of the most peculiar worlds in our celestial neighborhood. Uranus at a glance. Diameter, approximately 50,700 kilometers, about 4 Earth mass, approximately 14.5 Earth distance from Sun, 2.9 billion km, 19.2 astronomical units. Year length, approximately 84 Earth years. Day length, approximately 17.2 hours. Known moons, 27 plus. Composition: hydrogen, helium, methane, and Isis. Its pale blue color comes from methane in its atmosphere, which absorbs red light and reflects blue. The sideways planet Uranus is tilted at 98 degrees, meaning it essentially orbits the Sun on its side. Its poles, point almost directly at the Sun for part of its orbit, causing extreme long-lasting seasons that can last over 20 Earth years each. Why? Scientists believe a massive impact long ago knocked it over, possibly by a planet-sized body. Atmosphere and weather, though often seen as bland in telescopes. Uranus hides violent storms and complex weather under its calm appearance. Atmosphere contains icy methane clouds, and hydrogen sulfide wind speeds can exceed 900 kilometers per hour, 560 miles per hour. Temperature 224 degrees Celsius, 371 degrees Fahrenheit. The coldest planet in the solar system, unlike Jupiter or Saturn. Uranus emits very little internal heat. It's a mystery why it's so cold. A twisted magnetic field. Uranus has a magnetic field that doesn't align with its rotation axis and it's offset far from the planet's center. This creates a wildly lopsided magnetosphere that constantly shifts as Uranus spins, a phenomenon seen nowhere else in the solar system. Rings and moons. Yes, Uranus has rings too. They're faint, narrow, and dark, made mostly of large chunks rather than dust. Discovered in 197,713 known rings not visible from Earth with standard telescopes. And then there are the moon's many named after Shakespearean characters: Titania, Oberon, Miranda, Ariel, and Umbriel. Miranda, a scarred world one moon stands out. Miranda. Its surface is fractured, torn, and mismatched like it's been stitched together from different worlds. Miranda's cliffs are some of the tallest in the solar system, up to 20 kilometers high. Voyager 2. The only visitor. Uranus has only been visited once, by Voyager 2. In 1986, flew by in just a few hours. Captured first images of rings and moons, detected the planet's tilted magnetic field. Since then, no spacecraft has returned, but future missions may finally unlock Uranus's secrets. Why Uranus matters? It's one of the least explored planets. Its sideways spin and magnetic weirdness challenge planetary science. Its icy composition may represent a common type of planet in the galaxy. In fact, most exoplanets we've discovered so far are ice giants, more like Uranus than Earth. Neptune is the coldest planet, with the strongest winds, the fastest storms, and a deep blue hue that captivates astronomers and dreamers alike. Neptune's basic diameter, approximately 49,500 kilometers, almost the same as Uranus. Mass, approximately 17 Earth distance from Sun, approximately 4.5 billion kilometers, 30 astronomical units. Year length, approximately 165 Earth years. Day length, 16 hours. Known moons, 14 plus, including Triton. Like Uranus, Neptune is an ice giant, composed mainly of hydrogen, helium, methane, and ices like water, ammonia, and methane frozen under pressure. Atmospheric fury. Despite its distance from the Sun, Neptune has the fastest winds recorded in the solar system. Gusts up to 2,100 kilometers per hour, 1,300 miles per hour. Its atmosphere is a stormy, turbulent place. The most famous storm, the Great Dark Spot, was a hurricane-like storm as large as Earth. Spotted by Voyager 2 in 1989. It has since disappeared, but new storms keep forming. Methane clouds and blue color. Neptune's brilliant blue comes from methane absorbing red light, but its color is deeper and more vivid than Uranus, suggesting differences in atmospheric composition or clouds. Neptune's moons. Neptune's largest moon, Triton, is unlike any other moon in the solar system. Orbits backward. Retrograde orbits. Surface covered in nitrogen ice and geysers. Thin atmosphere, possibly a captured Kuiper belt object. Triton's active geysers spew nitrogen gas hundreds of kilometers into space, making it one of the most geologically active bodies we know. Voyager 2's grand finale. Neptune has only been visited once by Voyager 2 in 1989. Provided the first close-up images. Discovered rings, moons, storms. Sent back data that still shapes our knowledge today. Since then, Neptune remains a distant mystery. waiting for future explorers. Why Neptune matters? It's the solar system's most dynamic storm planet. Its moon Triton challenges our understanding of moons and capture dynamics. It represents the class of ice giants common in our galaxy. Neptune reminds us that even at the farthest edges of our cosmic neighborhood, the planets are alive with energy and wonder. Asterisk. From the scorching surface of Mercury to the icy storms of Neptune, we've traveled across the diverse worlds that call our solar system home. Each planet is a chapter in a story billions of years in the making. Story of formation, change, and endless mystery. But our journey doesn't end here. Beyond these familiar planets lie countless other worlds, dwarf planets like Pluto, vast belts of asteroids and comets, and the infinite expanse of space itself. Every discovery we make, every mission we send, expands our understanding not just of the planets, but of our place in the cosmos. The bigger picture, the solar system, is just one small part of the Milky Way galaxy, which itself is one among billions of galaxies in the universe. And as we continue to look outward to new stars, new planets, and perhaps new life, we realize how connected everything is. Invitation to wonder. So whether you're a scientist, a dreamer, or simply someone who gazes up at the night sky in awe, remember this: the universe is vast, mysterious, and waiting for us to explore. The planets are our stepping stones, guiding us to the stars, and maybe one day, beyond.